In this video, we're going to be taking a look at evaluating problems involving square roots. In other words, simplifying and solving for an answer. Here we've got 5 square root of 36 plus 7. So the first thing we need to understand is where does square roots, where do they fall under the category of order of operations, PEMDAS? Well, it turns out that in fact square roots count as exponents. That anytime we're working with things, that exponents and square roots are part of the same category. In fact, if I took a number and took its square root, I could write it as the number to the 1/2 power. Okay, this is not something you need to know right now, but just down the road, this might be something that comes up. But for our purposes, we're just going to be using the square root symbol. And once again, square roots fall under the exponent category. So now I've got an order in which to attack this problem. Parentheses, I don't see any. So exponents comes next. I want to do the square root of 36. So then the question becomes, well, now what do I do with this 5? Does this just become 56? Probably not likely. In fact, what this relates back to is problems like this. Let's say I gave you this. We know when something's written like this that this is 5 times 2 plus 3. And even though there's no multiplication symbol, because the 5 is right next to the parentheses, we assume that there's a multiplication symbol there. Well, that's the same thing here. 5 is right next to the radical symbol with no operation in between. So we assume, just like with parentheses, that there's multiplication in between. So now I can do the rest of the problem. Multiply and divide come next, which would be 5 times 6, which is 30. And then 30 plus 7 is 37. All right, let's try some others, but we're going to start working in some other types of numbers like decimals and fractions. Take a look here. At first, you might look at that decimal and think, oh boy, that's going to be trouble. But it's not that bad. 5 minus whatever the square root of 144 is. Now, or 1.44, I should say. Now, according to order of operations, we need to do that first. So let's put a little side note over here. Square root of 1.44. Well, what's really going on here is that we've got an easy situation here. We just don't see it because of the decimal. That if we just temporarily ignore that decimal, that this is the same thing as square root of 144, which has a square root. If you know your multiplication tables that high, it just turns out to be 12. So in fact, if we do this problem out, 12 times 12 would give us 144. Now, the other thing though we need to understand, and this is where mistakes can occur, we need to make sure that actually a decimal goes here. So does that mean it's going to be 0.12, or maybe it's going to be 1.2? Which of those will, when we multiply it, give us a decimal right here? Well, think about the nature of multiplication. The way we find how many decimal places to move the decimal over is by how many decimals are in the original problem. Now, keeping in mind that we're talking about squares and square roots, this number and this number have to be the same. So if I make it 0.12 and 0.12, I have to do them both like that. If I make it 1.2, let's reverse those. There we go. 1.2 and 1.2, again, they have to be the same. So we have to think to ourselves, well, which of those will give us a shift of 2 decimal places? Well, it was the second one, 1.2 and 1.2. 1 decimal place here, the second one here to give us 2 decimal places here. So basically think about it this way, is to get these 2 decimal places, one of the decimal places came from here, the other one came from here. So they get split equally. So in fact, what we get over here is 5 minus 1.2. Now, 5 minus 1.2, we just do the math, line up the decimals, and that would turn out to be 3.8. So a little trick for doing decimals and the square roots. Treat them as whole numbers, work them out, and then figure out where's the decimal going to go back into the problem. Now, what about fractions? Here's a problem. So take a look here. We have to find the square root of 18 over 2. Now, there are 2 different ways to tackle this problem. One way is to think to ourselves, well, and again, I'll put this to the side, that I am allowed to think of this as the square root of 18 over the square root of 2. But if you think about it, that really doesn't help us out, because 18 doesn't square root nicely. It's not what we call a perfect square. A perfect square would be a number like 16 or 25. And square root of 2. 2 is not a perfect square. A perfect square would be 4 or 1. So this really doesn't help us. So we can think about this a different way, though. Inside the radical symbol is division. And in fact, I am allowed to, since it's all contained within the square root, I'm allowed to do that first. So I could change this to the square root of 9, which now makes the problem so much easier, because the square root of 9 is just 3. So this would become the square root of 9. The square root of 9 is 3, and 3 plus 3 is 6. So notice how on this particular problem, dividing first inside and then square rooting that answer was the easiest thing to do. But then what about this last problem? We've got a very similar situation, 12 minus the square root of 1/16. So this time let's think about it the same way. Let's start off by looking at it as 2 square root problems instead of 1. I can think of this as the square root of 1 over the square root of 16, which in this case does work nicely, because the square root of 1 is 1. 1 times 1 is 1. The square root of 16 is 4, so this becomes 1/4. So now I've got 12 minus 1/4. But I think the important thing to pay attention to is notice how on this problem it was easier to square root the numerator and square root the denominator, whereas the last problem it was easier to divide first, get it down to a single number, and then square root it. So different techniques for similar situations. Now we finish it off. 12 minus 1/4 is 11 and 3/4. All right, so that's a little bit about square roots and order of operations. You'll be trying this out in your homework, so give it a shot and good luck.